Hi everyone, welcome to Mr. K's Simplified Maths. Today, we're diving into one of the core skills that you'll need for high school algebra, factorizing quadratic trinomials. If you've ever wondered how to break down expressions like x squared plus bx plus c into simpler forms, you're in the right place. By the end of this video, you'll know two different methods to factorize quadratic trinomials, the bridge method, and the cross method. So you can choose the one that works best for you. Let's get started. What is a quadratic trinomial? A quadratic trinomial is an expression with three terms where the highest degree is 2. For example, 5x squared plus 12x plus 4, where 5 is the coefficient of the x squared, 12 is the coefficient of the x, and 4 is the constant. Our goal is to factorize this trinomial, which means we're going to rewrite it as the product of two binomials. Basically, breaking it down into simpler terms. But how do we do that? That's where the bridge method and cross method come in. Let's start with the bridge method, which is very useful when the coefficient of x squared is not equal to 1. In this case, we cannot just look at the trinomial and factor it by inspection, so we need to use a structured approach. I'll walk you through the steps using this example, 5x squared plus 12x plus 4. Example 1. Factorize 5x squared plus 12x plus 4. First, multiply the coefficient of x squared with the constant term. Then, find two numbers that multiply to give us 20, and add to give us the middle coefficient, 12. By examining the factors of 20, we find the numbers are 10 and 2, since 10 times 2 is 20 and 10 plus 2 is 12. Now, form a product of two binomials using the numbers we just found, and then divide it by the coefficient of x squared. Note that the first term in each pair of brackets is always made up of the coefficient of x squared followed by x. Next, factorize each binomial where applicable. Finally, cancel the common factors. And that's it. The quadratic 5x squared plus 12x plus 4 is now factorized as x plus to 5x plus 2. Further examples for the bridge method. Example 2. Factorize 9x squared plus 40 for x minus 5. By examining the factors of minus 45, find two numbers that multiply to give us minus 45 and add to give us 44. We find the numbers are 45 and minus 1, since 45 times minus 1 is minus 45 and 45 plus minus 1 is 44. Next, form a product of two binomials using the numbers we just found, and then divide it by the coefficient of x squared. Now, factorize each binomial where applicable. Following that, cancel the common factors. Therefore, the answer is x plus 5 9x minus 1. Example 3. Factorize 6x squared minus 17x plus 12. Find two numbers that multiply to 72 and add up to minus 17. By trial and error, we find the numbers are minus 8 and minus 9, since minus 8 times minus 9 is 72 and minus 8 plus minus 9 is minus 17. Now, form a product of two binomials using the numbers we just found, and divide it by the coefficient of x squared. Then, factorize each binomial where applicable. Next, simplify the numerator by multiplying 2 and 3. After canceling the common factors, The answer is 3x minus 4 to x minus 3. Now, let's explore the cross method. Another powerful technique that's particularly useful when factoring trinomials where the coefficient of x squared is not equal to 1. Let's try this example 1. Factorize 5x squared plus 17x plus 6. First, ensure the terms are arranged in either descending or ascending order. Then search for a setup for terms such that the terms in each column multiply to give the x squared term and the constant term, respectively. One possible combination could be 5x and x for the first column, and 6 and 1 for the second column. To verify if this set of terms is correct, multiply them diagonally and add the two products. To check if the result equals the middle term, 17x. 5x multiplied by 1 and x multiplied by 6 do not add up to 17x. When the result does not equal the middle term, try a different set of terms and check again. Once again, the two products do not add up to 17x. Repeat this process until you find the correct set. Testing the third set of terms. Finally, the correct combination has been discovered. Now, simply place the terms from each row into brackets. The answer is 5x plus 2x plus 3. Further examples for the cross method. Example 2. Factorize 6x squared minus x minus 15. Pick your first set of terms. Multiply the terms diagonally and add the two products. To verify if the result equals the middle term, minus x. The sum of the products of the terms is not minus x, so select a different set of terms. Then test it again until you find the correct set. As you can see, the sum of the products is not exactly minus x. But this time it's very close. You only need to make it negative. Simply switch the signs of the terms in the second column and then check again. Found the correct combination. By placing the terms from each row into brackets, the answer is 3x minus 5 to x plus 3. Example 3. Factorize 9x squared plus 40 for x minus 5. Pick your first set of terms. Multiply the terms diagonally and add the two products. To verify if the result equals the middle term, 40 for x. If it isn't 40 for x, adjust your setup for terms, and then check it again. It's still not 40 for x. Refine your terms further. Once the correct combination is found, place the terms from each row inside brackets. The answer is 9x minus 1x plus 5. If needed, you can always expand the factors to check if they match the original trinomial. As you might have noticed, the cross method can take more time initially. However, with practice, it requires fewer guesses and checks. As you become more familiar with it, practice is key. Work through various types of quadratic trinomials to build confidence in your preferred method. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and share it with your friends. See you next time.